Okay, so clearly, will the number saying increase or decrease? Well, 10% of 800 is bigger than 20% of 200, right? So the number saying is going to go down by more than the number is going to go up. It's going to go up by 20% of 200, it's going to go down by 10% of 800. So I think we understand that. Everybody looks like they understand that. Whether you worked out the details or not, it's important to understand that sometimes you just have to look at the numbers and you don't have to do the detailed calculation. Although you're going to have to do it here, so if you did, that's no problem. Just understand that a little common sense will get you an answer here without having to hit it with a sledgehammer. Okay? Basically, this number is more than twice as big as this one. This percent is half of this one. And you just take those two observations and come to the conclusion. And it's always good to be able to do that. It's a deeper insight than just running through calculations, okay? And it looks like, from what I saw, that most people did the calculations well. Okay, then how many of each after 1, 2, 3, 4 months, okay? Well, I'm going to draw a picture. I've got 800, 200, right? And I'm going to draw a little arrow. 80, and another little arrow, 40. And we know why I have the 80 and the 40, right? This is I'm just going to use a capital S for sane, okay? And of course those sane are going to go into the demented column. And I have 20% of the demented that are going to go into the sane column, right? So the net change is going to be 40. So this is going to lose 40, it's going to gain 40, right? So we're going to have then, and I'm going to write it out in detail, 800 minus 80 plus 40, and I'm going to have 200 plus 80 minus 40, and that's, of course, going to give me 760 and 240. Everybody agree? Did you get those numbers? Mm-hmm. Good, because I was worried about my arithmetic there. Okay? Make sense? Now, you might not have drawn it out the way I did. There are many ways you could do this. You do it in columns and stuff. But a picture that kind of shows how things are related can be helpful. Okay? And then we could do the same thing. You know, we're going to have 76 that go this way, and 96 is 20%, 48 that go this way. Okay? And we get these numbers, and then these numbers, and then these numbers, right? So what did you end up with after 4 transitions?
698 sane and 302 demented.
Again?
698 sane.
698?
Mm-hmm.
Okay, do you have any decimals in there?
We did, but there were people.
Did you round them off?
Yeah.
Okay, don't.
Don't round them off?
But that's all right. No, don't round them off. We can have fractions of sanity and dementedness. Okay? You know, if somebody is, if you have, never mind. Just, we're gonna deal with fractions. Okay? Because we want to get precise answers ultimately. Mm-hmm. But it's okay for this exercise. You understand the process, and that's all we're doing. So you got about, what'd you say, 698?
Yeah.
And that means you must have had 302 here.
Yeah.
Okay? Did anybody carry out the decimals?
I did.
Yeah.
I had 698.68 sane and 301.32.
0.32.
Yeah.
Do you mean 0.322 or 382?
No, there's not a 1, it's just 6.8.
Oh, it's 6.8.
Yeah.
So again, I'm hearing things. Auditory hallucinations, it's a sign of sanity. Okay? Okay, so 301.32. Okay? And of course, these numbers add up exactly to 1,000, right? Okay? Because if you start rounding off, what's going to happen is eventually, if you do this for like, you know, a lifetime, you're going to end up with something different than 1,000. Just because of the way the round-offs work, okay? And you don't have to worry about that. But that's one reason not to round off. The other is You don't know, what if you wanted to scale this up to 10 million people? You'd need all those decimals, wouldn't you? Because those decimals would not become decimals anymore, okay? Scaled up to a million, you're gonna have 698,680, right? Okay? And sometimes we wanna scale things up.